Hi everyone, I'm Orkun GENÇ. I'm an undergraduate student in Bilkent University. For the term project of the course EEE 102, Introduction to Digital Circuit Design, I have performed a project that everyone is familiar with during their lives. Everyone has a problem of carrying their baggages in the airport till the counter officers take them to the plane. With my project, the control will be held by the passengers, and they can send their baggages at the entrance of the airport to directly the counter where they have to make a check-in. The project is a treadmill that carries the baggages of the passengers at the airport, and the treadmill will be working when the passengers wants it to work, and then the working process continues till the baggage is sent to the storage. The baggages have ID cards in front of them that makes it easier to separate them and send them to the counters where the flight numbers are directed to. Thus, with this project, the passengers will overcome the problem of carrying their baggages in the airports till they reach the counter to make a check-in. And the project demo has a design just like this. And we have basis tree here, and the basis tree is connected to the circuit design on the breadboard, and there is a proximity sensor on this breadboard which is directly parallel to the platform of the treadmill, and the circuit is connected to the DC reduced motor here, and when there is an object here and the passengers let it to slide, this system will work, and there is a voltage across the motor, and motor starts to turn the wheels, and the platform will be circulated till the baggages drop to the box that works as a storage in the airport. Let's have a look at the circuit on the breadboard, which makes the connections and the real work of the treadmill digitally. Basis tree, which works as the switch of the circuit in the right hand side, and the basis tree is connected to the proximity sensor, which gives two important data that are trigger and echo, which help us to measure the distance of the obstacle that is preventing the ultrasonic sound waves coming through the sensor back again. And this sensor is connected to a voltage supply and ground to make it easier and to not have such a mass of connections. I have used a USB cable to connect the sensor to a computer, which makes it both a ground and supply. And the output of the basis tree, which is 3.3 volts, it is connected to a MOSFET here as a gate. A MOSFET works like this: if there is a voltage on the gate, then the drain and source are connected to each other, but if there is no voltage on the gate, they are not connected to each other. Thus, the system is working as a switch of the circuit on the right side. If there is an object that is caught by the sensor, then the basis tree is coded to make an output of 3.2 volts to the MOSFET and connect these two drain and source, which makes a complete circuit on the right hand side. And if there is a complete circuit on the right hand side, the motor is taking the voltage on the supply and starts to work. And there are diode, LED, and resistance parallel to the motor. Diode is used for preventing the back voltage of the motor. When the pin starts to turn, there is a voltage provided by this pin, and to overcome this problem we use the diode. And there is a resistance and LED. LED is used to show that the motor is working, and it is not when these are not connected to each other, and the resistance is used to not the LED burn. Let's have a look at these connections on a basis and breadboard. The sensor is connected to the basis tree, and basis tree's ground and output are connected on the breadboard. The output is directly connected to the MOSFET's first leg, and the second leg is connected to the circuit, and the third is connected to ground. you can see the important details on this MOSFET in its datasheet. I will make them at the end. I will show them at the end. The circuit has a diode here connected, a resistance and the LED, and there is the motor that we are using for the platform, and this motor is also connected in this parallel design, and the sensor is connected differently from these all to a supply, and these are the connections of the sensor and the basis tree. Before looking at the demo, let's have a look at the digital components and the codes of the project. In the coding part, we have two different modules. Inside the top module, we have in top module we have clock and echo as an inputs, and motor out, trigger, segments and anodes are the outputs of the top module. In top module we have two different modules, as I said. The first module is 7-segment module. In this module we have a part that looks for the 7-segment display of the distance between the sensor and the object on the platform. A measure is a different module that is containing of the range sensor module and several if statements that reaches out the result of the distance with the measured echo time. Inside this measure we have range sensor. This range sensor is the place where the echo time is experienced, and by this echo time the result is calculated inside the measurer, and with this result value the 7 segments is